Imagine the calendar reading the year 2500. Humanity's first spacecraft designed to leave the Milky Way has just moved beyond the galaxy's most distant star. This long-awaited milestone is being streamed across every world where humans have settled. The craft is called Wanderlust 1, and its mission is to push toward the nearest major galactic neighbor, Andromeda. Just as countless viewers begin celebrating this achievement, something unexpected unfolds. A sudden impact, generated by speech eyes. The central portion of the probe collapses inward as if crushed by an invisible force, its metal skin warping, tearing, collapsing, and in some places seeming to disappear entirely. What remains spins lifelessly through space, its systems silent, until the cause becomes unmistakable. Wanderlust 1 has collided with a primordial black hole. The scenario is, of course, fictional, generated by speech eyes. But the type of black hole described, incredibly tiny objects with masses comparable to that of a fully grown rhinoceros, may not be imaginary at all. They might exist along the edges of our galaxy, and new evidence suggests we may finally have signs of them. Together, we'll explore what primordial black holes may be, where they might originate, and whether they pose any danger to us. Generated by speech eyes. For decades, the scientific community believed that extremely small black holes, the black hole rhinos, as we'll refer to them, simply couldn't form. Before the 1960s, only one black hole formation process was known: the collapse of a massive star. If a star at least 20 times the Sun's mass exhausted its fuel, it would explode as a supernova. Generated by speech eyes. After the explosion, the remaining core could compress so tightly that its gravity prevented even light from escaping, the defining property of a black hole. These were labeled stellar black holes because they came from stars. Stars smaller than that don't follow the same path. Stars with less than 20 solar masses still undergo supernova explosions, but their collapsing remnants do not reach the extreme densities needed to produce black holes. Generated by speech eyes. Instead, they form neutron stars, compact bodies overwhelmingly composed of neutrons. Below 8 solar masses, stars don't explode at all. This means that stellar black holes have a predictable mass range. They can't be born heavier than the most massive stars, and they can't be born lighter than a few times the Sun's mass. So why believe that black holes far smaller than this limit could exist? Generated by speech eyes. Strangely enough, the journey to that answer began by discovering black holes much larger than theory allowed. Modern astronomy has revealed that most large galaxies contain a colossal object in their center, a supermassive black hole. The first signs of these came in the 1960s, when astronomers detected quasars, exceptionally bright, distant galactic cores, beginning with a landmark discovery in 1963. Generated by speech eyes. Through the late 1960s and early 1970s, evidence mounted that these luminous centers were powered by unimaginably massive black holes. By 1971, scientists had formally proposed that galaxies hosted black holes hundreds of thousands to billions of times more massive than the Sun. Yet they had no explanation for how these monsters formed. Could stellar black holes have consumed enough matter over time to reach such enormous sizes? Generated by speech eyes. Possibly, but discoveries of ancient supermassive black holes began to raise problems. The older the universe we observed, the less time black holes would have had to grow. But more and more examples of extremely ancient, extremely massive black holes kept appearing. Then came a shift in what telescopes could see. The launch of the James Webb Space Telescope on the 25th of December 2021, and its activation in 2022, promised unprecedented clarity of the early universe. Generated by speech eyes. Webb was engineered to detect the faintest, most distant light, originating from near the beginning of cosmic time. It delivered. Webb identified galaxies marked by tiny red points whose light had taken more than 13 billion years to reach us, only about 500 million years after the Big Bang. Some of these galaxies already hosted fully grown supermassive black holes. Generated by speech eyes. That timeline shouldn't allow stellar black holes to expand to those sizes without consuming matter faster than physics should technically permit. Although some researchers argue that black holes can grow surprisingly fast, in ways previously thought impossible, many remain unconvinced. This disagreement keeps alternative explanations alive, including one idea that the James Webb Telescope may have indirectly supported. Generated by speech eyes. Black holes require extremely high densities. When mass becomes concentrated enough that its gravity creates an escape velocity faster than light, the material collapses into a black hole. To reach that point, matter must overcome electromagnetic repulsion that prevents subatomic particles from being pushed too close together. Neutron degeneracy pressure, a quantum mechanical rule preventing neutrons from occupying identical positions. Generated by speech eyes. Even neutron stars, ultra-dense bodies where a teaspoon of material weighs around 900 billion kilograms, roughly the mass of Mount Everest, cannot overcome neutron degeneracy pressure. To form a black hole, Everest's mass would need to be compressed into a volume more than 1,000 times smaller than an atom. Today, such extreme conditions occur only inside collapsing stars. But go back to the universe's earliest moments, and the situation changes drastically. Generated by speech eyes. Within the first second after the Big Bang, the universe was a hot, dense mixture of particles. Conditions were uneven. Some regions had greater concentrations of matter than others. Physicists have proposed that in areas where density briefly spiked high enough, matter could have been compressed directly into black holes, without needing a star. These theoretical objects were named primordial black holes, first suggested in 1966 by Yakov Zeldovich and Igor Novikov. Generated by speech eyes. Remarkably, primordial black holes could have formed with an enormous range of sizes. Some may have been massive, more than 100,000 solar masses, providing seeds for the supermassive black holes seen today. Others might have been extraordinarily tiny, black holes as small as atoms but with the mass of asteroids, or black holes no larger than protons yet with the mass of a rhinoceros. But these tiny black holes face two problems. Generated by speech eyes. First problem: Hawking radiation. Stephen Hawking proposed that all black holes emit an extremely faint radiation that causes them to lose mass. Over billions of years, the smallest black holes should have completely evaporated. Second problem: no confirmed sightings. No one has ever directly observed a black hole forming from raw interstellar matter, or had not, until a recent discovery forced scientists to reconsider. Generated by speech eyes. In July 2025, NASA announced that James Webb had imaged two disk galaxies likely colliding with one another. But between them, not located in the center of either galaxy, Webb detected a third supermassive black hole. Neither galaxy had ejected it, because both retained their own supermassive black holes. The object's location made no conventional sense. Researchers suggested that this rogue black hole might have formed independently through the direct collapse of a massive gas cloud. Generated by speech eyes. And this wasn't the only anomaly. Another Webb target, QS-01, revealed a supermassive black hole residing in a surprisingly small and chemically primitive galaxy. Spectral analysis showed the galaxy possessed less than 1% of the oxygen found in the Milky Way, indicating extremely low levels of heavy elements. Heavy elements form inside stars, which means very little stellar activity had occurred. If few stars had formed, then few stellar black holes could have existed to merge or grow. Generated by speech eyes. This strongly implied that QS-01's black hole did not originate from a star. These findings don't prove primordial black holes exist, but they strongly hint that the early universe produced black holes directly from dense gas, which supports primordial black hole theory. If massive primordial black holes formed, tiny ones likely did as well. But weren't the tiny ones supposed to evaporate? Maybe not. Generated by speech eyes. Astronomers have long known that galaxies possess far more gravity than visible matter can explain. This requires the presence of an unseen substance, dark matter. Many believe dark matter forms enormous halos around galaxies, including the Milky Way. But what if some portion of that invisible mass isn't exotic particles, but tiny black holes? Large black holes are ruled out. Their gravity would fling stars around unpredictably and distort background starlight through gravitational lensing. Generated by speech eyes. Since observations don't show such disturbances, massive hidden black holes can't account for dark matter. But microscopic black holes, especially ones without accretion disks, would be extremely difficult to detect. Their small sizes would make lensing effects nearly impossible to spot. The main objection has always been Hawking radiation. If tiny black holes evaporate over time, none should remain. Yet this claim may need revisiting. Generated by speech eyes. In April 2024, a paper in the monthly notices of the Royal Astronomical Society proposed that Hawking radiation may slow dramatically when black holes reach incredibly small sizes. At minuscule mass scales, evaporation could almost stop entirely. If true, primordial, black hole rhinos might still exist today, surviving from the dawn of the universe. Generated by speech eyes. This raises a provocative possibility. Perhaps some portion of dark matter consists of countless tiny black holes orbiting in a massive halo around the Milky Way. Not a smooth cloud of exotic particles, but a swarming minefield of microscopic gravitational objects. Millions, maybe more, could be out there. And if humanity ever attempted to leave the galaxy, we might unknowingly pass into a region filled with them. Generated by speech eyes. Deep space travel already carries enormous risks, but contemplating that a barely visible black hole with the mass of a rhino could silently drift across our path, or even approach the solar system, is unsettling. If this theory proves true, it might be wise to worry less about venturing beyond the galaxy. A hidden ocean of tiny black holes might pose dangers humans have not yet accounted for. Generated by speech eyes. Until we find decisive evidence disproving the idea, the safest option may simply be to remain where we are. Thank you for watching. Generated by speech eyes.